Okay, so in this video, we're going to revisit the implementation of Python in the Spyder environment, and we're going to estimate the Leisen Reimer tree. And this code is available at the, just mentioned this GitHub here. Right, this one here. So we need to go into open up Anaconda, right? And that might take a second. So let's just pause while that takes place. And the Anaconda navigator has opened up. So we'll launch Spyder. I'll just take a second, and we might pause for that as well. And we have, if we check here, we have Spyder, and we will implement, okay, so we need a new file, and we just paste in. Okay, paste. So that's our code. Now we can remove the pound sign just to make everything live, and basically we will have a European value of a call, European value of a put, American value of a call, American value of a put. So we'll run this, and then the parameter values that I have here that we set out in the estimation are the same as those. They're consistent. Let's take a look. Are consistent with the arguments in table 1 of Leisen Reimer 1996. So for the American put option, the parameter values that we have for S, X, T, R, B, or C, cost of carry, is 0.07, volatility 30%, and N is equal to 25. So let's run that, see what we get. And we have to save. Okay, let's save as Leisen Reimer Python. Okay, and we have some output. Now we've an error. Let's just check Leisen Reimer output flag, American flag. Okay, so I need to put the pound sign in here. Now run, should be fine. Okay, so we have the output here. The price of the Euro, let's view this. The price of the European call option is 10.13. The price of the American call option is 10.13. The price of the European put is 6.69. And the price of the American put option is equal to 702,857. And we can check that against the output we had previously for Leisen Reimer, where when we had these arguments for the put option, we got 7.02857, and that's the same as what we have here. Okay, now if we want also delta and gamma, we can say A for all, not American, but also instead of price, we'll say all, so delta and gamma, because this code allows for not just the price, but also the price of the varying options, the respective deltas and gammas. Let's run again. And you can see here we have the delta, gamma, and price for the European call, delta, gamma, and price for the European put, the American call, European put, delta, gamma, and the price. and the American put a little bit more valuable, delta, gamma, and the price of the put. We can look at the file explorer, the variable explorer, and we have that also tidy, more tabulated output. So again, the price, the delta, the gamma, the price, the delta, the gamma. For the European call and the American call, you'll notice that the value is the same. For the American put and the European put, you notice that the American put is slightly more valuable, and that's because we don't have different yield and the interest rate is greater than 0.